Good morning class. This is your another practical for the LCR circuit where three inductor, capacitor and resistor are connected in parallel, and here we will trace the graph and also calculate the frequency for such LCR circuit where three of these terminals are parallel in nature. So here for the apparatus, for the input I am having audio frequency oscillator. So oscillator will provide input to the parallel LCR circuit. LCR kit is there and multimeter and connecting wires are there. So here in the diagram as I have shown here, L and R are connected where C is in the parallel to that L and R, inductor and capacitor and resistor. Three of these are parallel in nature, and on the terminal CRO we will display the frequency and voltage. What amount of voltage and frequency we require, that will be on the CRO, and function generator FG is there. So here we will have the values frequency and resistor. So beta, this is LCR circuit where I will use the parallel one, okay, and this is the function generator or signal generator from where I put the knob here and I will vary frequency of up to 10 kilohertz at these terminals, okay. So this is the input which I have connected at this, means this is the audio frequency source which I have implemented on the input end. Here is the resistance and value of the resistance is 1 kilo ohms. So resistance is parallel to the inductor and inductor is of 12 millihenry, and here capacitance I have used C4, okay. So these terminals are open, means these are not connected. Connection is with C4. So here output is also at these terminal. One output is grounded at this point and another output is at C4 end. So here R, L and C, three of these terminals are parallel in nature. R is parallel to L is parallel to C, and output is at the knob of C4. At the output terminal I use the grounded point for the second output point. So here frequency is of 0.656 value in kilohertz. So if you transform from kilohertz to the hertz, that will be 656. Along with that, voltmeter gives us the reading of 0.038. So if you want to vary the frequency, you can use this knob. So along with that, frequency will be variable. So this is how, with the change in these terminals, similarly I can trace the different values of the frequency and voltage. So this is how you can go ahead for the parallel resonance, parallel circuit for the LCR circuit, okay. So I will trace the values of frequency and voltage. From that I can go ahead for the current also. So beta, once more I will tell you the circuit diagram. Here is the input is at this point. One terminal is grounded, okay, grounded one, another terminal is connected at this point. So input of this much frequency I have supplied to this parallel circuit. Resistance is of 1 kilo ohms which will use that frequency. So resistance is connected to this inductor. So this is how inductor is connected, 12 millihenry. So this one inductor I have used. Now output is at this point, so one point of the capacitor is at this point and one point of the capacitor is in the connection with the inductor. So this is how the whole apparatus you can operate. So here LCR is in the parallel and the reading you can go ahead with this display. So here I am having values, that is inductor I have used of 12 millihenry, resistance 1 kilohenry, and frequency which I used, that was 655 hertz. So if you want to calculate that frequency, you can go ahead with the formula of 1 upon 2 pi under root LC. Inductors and capacitance value is there in the circuit, so you can use those values. XL is the inductor's resistance, that is 2 pi FL. So whatsoever frequency is there, that is F, and L is 12 millihenry. So quality factors formula, whole the formulas are based upon these values. Q is equals to R upon XL. R is the resistance of 1 kilo ohms and XL we have calculated. Similarly, bandwidth of that parallel LCR circuit we can calculate with the formula of F upon Q. So lowest band value and highest band value is there. Similarly, IR and IL you can calculate with these values. Thank you so much class.